Since our goal is to do calculus involving logarithms, it's natural that we start with limits and then we'll move to derivatives and integrals. So if we look at the definition of the natural log as the definite integral from 1 to x of 1 over t dt, what we find is that this graph looks like this. As we go towards 0, it shoots off to negative infinity. As we go towards positive infinity for x, we go towards positive infinity for the function, so it eventually gets there. And then we have an x-intercept at 1, 0. So our domain is every positive number, and our range is actually all real numbers. So let's apply some limits. The first thing is this limit as x approaches 3 from the positive side. Notice that we have to do a one-sided limit, because if I approach 3 from the negative side, I could plug in something like 2, and I would end up taking a log of a negative number, and that's not valid. So as x approaches 3, natural log of x minus 3 gets very, very close to 0. So what happens as I get very close to 0 is I go towards negative infinity. So that limit is not finite. Next, I have the limit as x approaches 4 from the left of this expression. Now, you could evaluate this directly. That wouldn't be a problem, but let's use some of those log rules that we just developed to try to see if we can't do some more clever things. So this would be the limit as x approaches 4 from the left of the natural log of x squared plus the natural log of 5 minus x. And then at that point, we could evaluate this. Now, if I plug in 4 here, I get natural log of 16, and then I get natural log of 1. Natural log of 1, though, is 0. So what that tells me is that this term actually vanishes, and I'm left with the natural log of 16. So that's not too bad. Finally, we have the limit as x approaches 2 from the positive side. And we have to do that because we want to avoid running any issues here. We don't really have to do it from the right-hand side, but if we do it from the right-hand side, we guarantee that we don't accidentally plug in something badly. So we can again use logarithmic rules to expand this. We don't really have to, but to practice those, we can say, all right, that's the limit as x approaches 2 from the positive side of natural log of x minus natural log of the square root of x minus 1. But remember, the square root is like a 1/2 power, so we can say the limit as x approaches 2 from the positive side of natural log of x minus natural log of x minus 1 to the 1/2 power. And then we can bring that 1/2 to the front. We can say the limit as x approaches 2 from the positive side, natural log of 2, or natural log of x minus 1/2 natural log of x minus 1. Now we can try direct substitution. We can say, okay, well that's the natural log of 2 minus 1/2 the natural log of 2 minus 1, which is 1. But again, we know that the natural log of 1 is 0. So this term vanishes, and we're left with the natural log of 2.